First part in translating parent functions to know which one you're working with. So in number 1 here, we are working with a linear, which is y equals x. Number 2, you know this is x squared, but you're going to have to use the vocabulary quadratic. Number 3 kind of looks quadratic because we have that side, but we also have the negatives, which means now we're up to x to the 3rd power, which is cubic. Number 4, hopefully most familiar with this one at this point, that's the absolute value. And number 5 is the square root. Okay, it can also be called the radical. We keep it the square root. To know how it moves, we have 3 parts. How does A, doesn't matter what it is, how does A affect it? Well, if it's something like 2, that gives you a vertical stretch because it's going to make it taller. If it's 1/2, it's going to be a vertical compression. And if it happens to be negative, it's going to give you an x-axis reflection. H is on the inside of your function. Okay, so it looks like x minus 8 squared. It looks like absolute value of x minus 8. It looks like the square root of x minus 8. Okay, all of these, since it says minus 8, and we think of minus being to the left, it's going to go to the right 8. So this is a left and right movement, and it's always backwards. What does k do? K is a number added or subtracted to the outside, not multiplied. Added or subtracted, it's going to be either up or down, and it's true to what it says. So plus 8 would be up 8, minus 3 would be down 3. Let's take a look at a couple of them here. So we're going to work with x squared. Alright, so x squared, that's your quadratic. Transformation number 1. I don't really care about the order here, so I'm going to start with the easiest thing. Minus 6 afterwards, that's on the end. It's down 6. Inside, minus 1, it's right 1. And we have 3 in the front. 3 multiplying by 3 is going to make it taller, so it's a vertical stretch of 3. Number 7 here, I have x to the 3rd power. Okay, that's a cubic. I'm going to work in the same order. Minus 11, down 11. Minus 2 on the inside. That's right 2. This time it's multiplied by 5. It's still greater than 1, so it's a vertical stretch of 5. Next one we have is the absolute value. There's nothing on the outside that's being added or subtracted, so it doesn't move up or down. If I have plus 6, that's left 6. Inside is left and right, and it's opposite. It's multiplied by 2/3. That's less than 1, so it's vertical compression of 2/3. Last one we have in this section is linear, right? X to the 1st power, it's linear. The only transformation we can do to linear is move it up or down. So this one is up 6. Alright. Some things you might be asked to do with it is then graph it. So we see x squared. I'm thinking this has to be x squared. I'm thinking it's a U shape. We have to go down 3, and we have to go to the left 2. So left 2, down 3. The a value is 1, so we'll use a normal U shape. Number 19, minus 3. We're going to go to the right 3. We're going to go up 2. Right, up 2 because the plus 2. The a value is 2, so we're going to make it taller. I go up 2 and over 1, up 2 and over 1. A nice tall V shape because it's the absolute value. Number 20 on here. You don't have this paper, but it's alright. This is linear, so do like you normally would. Start up 5, 2, 3, 4, 5. We're going to go down 4 and over 1. Okay, transformations. This is the only thing that gets a little bit tricky. Right, it's up 5. Negative 4 is 2 parts. It's a vertical stretch of 4, and the negative makes it an x-axis reflection. Okay. We like to use the common term of it's upside down. But this is what we call it. And the square root, just because we didn't do a ton of those, this is inside the square root. So it is the same thing as the inside part here or the inside part here, which means we're going to go to the left 5. 1, 2, 3, 4, 5. And we're going to apply the regular square root function. All right, so that's a recap on translating functions.